So in the question, it has been given that there is gun of mass 4 kg which fires a shell of mass 200 grams. And in this process, 1.05 kilojoules of energy is released. So what is initial velocity of shell? So what exactly we mean by 1.05 kilojoules of energy is released is that when explosion take place, I can say the energy is equivalent to increase in kinetic energy of system. So the energy of explosion is nothing but increase in kinetic energy of your system. So if I consider my system to be, let this to be a gun whose mass is 4 kg and it has shell of mass 200 grams, which is equal to 0.2 kg. So what is initial momentum? Initial momentum of your system is 0. And what is initial kinetic energy? Initial kinetic energy is also 0. And now when shell has been fired, let it be moving with certain velocity u, then this gun will be moving in backward direction with velocity say v. Why? To conserve momentum because no external force is acting on system. So finally also momentum should be 0 because initial momentum was 0. So this shell will be moving in forward direction and this gun will be moving in backward direction. But one thing I can say, momentum of both of them will be same as far as magnitude is concerned. Right? If you consider their direction, definitely this momentum is positive and this momentum is negative. But magnitude wise, they are same. This is plus p and this is minus p. So total momentum of system is still 0. Initially was also 0. But now what is kinetic energy of this gun? It can be written as p square by 2. Let it be capital M. Let the mass be capital M and its mass be small m. So what will be kinetic energy of this shell? It will be p square by 2m. So we don't know that capital M is 4 kg and small m is 0.2 kg. So what is total final kinetic energy? It is p square by 2 capital M plus p square by 2m. So whatever is final kinetic energy, that will be difference in kinetic energy because initial kinetic energy is 0. So this is difference in kinetic energy or increase in kinetic energy, which is nothing but energy released in explosion, which has been given to be 1.05 into 10 to the power 3 joules. So let's solve this to calculate this P. So P square by 2 I am taking common. So this is 1 upon capital N plus 1 upon small n will be equal to, I can write this to be 1.05 into 10 to the power 3. And this is P square by 2 capital M plus small n. This is small n, this is capital M. So both of them will be equal to 4.2. And here I will get 4 into 0.2. This will be equal to 1.05 into 10 to the power 3. So P square will be equal to 1.05 into 4 into 0.2 into 2 into 10 to the power 3 divided by 4.2. So let's try to solve it. I can say this is 105 and this is 420 into 4 into 0.2 into 2 into 10 to the power 3. So this 105 can be written as 35 into 3 and this 420 can be written as 7 into 60 into 4 into 0.2 into 2 into 10 to the power 3. So this can be 7 into 5 and this can be 12. So this is 4, 4 get cancelled. So it comes out to be 0.4 into 10 to the power 3 or 400. So from here I can say this p square is coming out to be 400, which implies p will be equal to 20. Now I have to find momentum of this shell, which is nothing but m into u. So m into u is 20. M is 0.2. M, that is mass of this shell, has been given to be 0.2. M into u will be equal to 20, which implies u will be equal to 100 meter per second. And I've solved this without using any calculator. So since you are NEET aspirant, you should be uh, quite comfortable with such types of calculation. And your speed should be, in fact, you should be faster than me. So final velocity comes out to be 100 meter per second, which is nothing but option C. So answer is C.